afternoon. Good afternoon for all of you. Some of you already PM me about the fourth question, but I looked through the question. It is not like from 5-1. Anyhow, I will try to answer you also lah. Alright. If you got any question, then you can ask in the Telegram group or you can PM me directly in WhatsApp. Alright. So first of all, if you are not my student, all right, you are welcome to join my tuition also. All right, so the detail, you can click the link below or contact the number. All right, that's the first thing. All right, so okay, now today, because of some of you request me, Jegu can do the revision for inertia and force or not. All right, so no, inertia is the one that you request, right? But the force, I can see your that one, your quiz is not doing very well, right? That's why I'll plan to do one. And then inertia is the one that you request, and then the other one, it is energy. Although it is removed from the from 5 KSSM force, under the force. Previously, it is under the forces chapter, force and motion. But now it is removed already. But anyhow, many questions asked, it is related. So you have to understand also. Right? I guess you have learned it in lower level, like Form 1, Form 2, Form 3. Right? Maybe lah, because I'm not teaching Form 1, Form 2, Form 3. Right? Anyhow, so let's go for the first thing. All right, today the thing that we are going to see is inertia. All right, this is my notes. We have done it already, this one, but we just go through very, very fast and briefly go through lah. So okay, now, so inertia, what is inertia? So inertia is tendency. All right, the keyword is tendency of the object to remain at rest. Right, when it is at rest. Right, tendency of the object to remain moving. All right, if it is moving, right, then it will continue to move in a straight line with uniform velocity. What is this? This is actually Newton's first law. Right, Newton's first law said that the object that is stay at rest, it will continue to stay at rest. An object that is moving, it will continue to move in a straight line. Right, if there is no external force, unless there is external force act on the object. Right, so most commonly where it is asked. All right, now okay, teacher, I still don't get it. All right, okay, never mind. Now 10, right, you look at this word of 10, right? So what is mean by 10? If a boy, it is standing at here, right, it will tend to stand at here. 10, right, it will still want to stand at here, right? If there is nothing to push it, right, right? Yeah, it is memang like that. So if a boy that is moving already, he is running, so it will tend to run, unless got something to stop it. You got something to block it, then it cannot move forward, right? Tend to run, right? So what is the example in the daily life? All right, so this one is mostly come out in essay. All right, so for example, the most important thing, the thing that you need to know is, the larger the mass, the larger the inertia. The larger the inertia, larger the acceleration, the larger the inertia. This is two things that you must know. Right, it is different from momentum. Momentum depend on mass and velocity. This one depend on mass and acceleration, right, or deceleration. Right, that's two different things. So you need to know what is inertia. Okay, now let me make it simple and easy. All right, you watch this video first. Give me 1 minute. All right. Okay. All right. I show you these two video. All right. So a coin. All right. Now we talk about this coin. We talk about this coin. I take one example enough. If not, it will take so long time to finish everything there. So this coin, it is at rest, right? Right now, it is at rest. So what happened is, it tend to be at rest. It still want to be at rest, right? So now what happened is, if you push, you jerk the cardboard, right? The cardboard, so you got one acceleration already, when you jerk the cardboard. So the cardboard move forward. So this coin remain to stay at rest. Remain to stay at rest. So remain to stay at rest mean it will stay at here. This coin will stay at here. You stay at here. Even this one move away already. This one, the cardboard move away already. So this coin still tend to stay at rest at here. So what happened? Nothing to support it, then it will go down. So this is inertia. Now of course you ask me, how about I don't jerk? Alright. How about I don't jerk it? I move it slowly. So the coin will follow to move, right? Now this is not inertia, right? Yeah. Then how can it be not, right? So you see, what is Newton first law said, right? Newton first law said that it will remain at rest, right? Or continue. If it is moving, it will continue to move in a straight line with uniform velocity unless you act an external force. So this is the external force. We know that the force is equal to ma. If you got acceleration, then you got an external force, right? If you got no acceleration, you move with uniform velocity slowly, then this is no inertia, right? Not inertia, right? So now it will not tend to stay at rest. So you need to know this, right? Just now I show you the video. All right, second one, it is a dog. All right, a dog. I don't know how to draw the dog. The dog shake their body, right? So let's say this is the body of the dog, right? So this is the water droplet, right? So what happened is, the dog shake his body, right? Shake his body, the water, it is at rest. Right now, it will tend to be at rest at here, right? So when the dog's body shake to here already, right? The water droplet still at here, but need to shake very fast, right? So move slowly, tidak boleh. Alright, so this is inertia. So now we try to have a look on some example previously. Now a truck and a motorcycle, it is moving at the same speed. Both are reaching the traffic light and get to stop. Get to stop means you decelerate. When you decelerate, your body will move forward, right? If you are driver, your body is moving forward. That one is inertia already, right? But I explain how the heavy truck, it is unable to stop in a short time. So you need to explain. Normally this one is 3 mark to 4 mark, but this one I don't give any mark here. So you just explain as this is the example I make on my own. So you need to know, the larger the mass, the larger the inertia. So the truck, heavy truck, the keyword is heavy truck, large mass. All right, keyword first one so inertia, it is big, right? Inertia, it is big. So when inertia, it is big, it is hard for it to start to move forward, and it is hard for it to stop in a short time. Now I show you actually actually the question that I make, but I didn't give you, right? Wait more inertia momentum. Inertia. Give me 1 minute. me see. No, this one. Give me 1 minute. Okay. All right. All right. Try to have a look on here. All right. This is the question that I made, but I didn't give you because the mark is like I can give you is 3 marks, so I changed that one. I changed to other question, right? So you see, if this is a truck, right, you bring a lot of mass, right? So when you want to start to move, you can start to move or not? No, very hard to start to move. Why? Because the inertia is big. So when the inertia is big, then very hard to start to move, and then very hard to get to stop. All right, so this is the maximum limit that can load by the car. So you cannot too heavy then cannot start to move, right? Not cannot, hard, right? That's why I said the larger the mass of the object, the harder the object to start to move, right? This is inertia, right? The larger the mass, the harder the object to get to stop, right? But this one is turning to stop, right? When you want to get to stop, so you don't need to talk about hard to get to start, right? So when the inertia is big, your mass is big, you want to brake, very hard for you to brake. So don't write the word of brake. So you follow what they gave, right? Unable to stop in short time, unable to stop in short time. Inertia is big, right? So this is the all the situation of the inertia in daily life. All right. Now, I don't want to give you all of this one already. I gave you before in my notes. Also got. All right. Now, how to reduce the negative impact of the inertia? So you put in a steel structure. So what happened if now this truck already know the mass is big already. So when you move fast, then it is hard to stop, right? Even you stop, you see, hey, let's say you got that is a guy jump out at the middle of the road when you are moving, right? You are bringing the truck. So when you stop, boom, this one it is going to move forward. So how to stop it? You need to use steel structure. First one, steel structure, it is hard so that it can protect. It can protect the goods here to move forward and then hit the driver seat, right? I gave you a video before, right? It is very dangerous. This one move forward, but anyhow this one will patah anytime, right? So the next thing if you can do is move this one. You see this one, this driver compartment, you can have driver compartment is far, right? This is the goods. It is far from the driver's seat, right? Of course, steel structure it is. You need a steel structure, right? So when this one is far, when you brake, even this one patah, then it still got distance to move forward. It is can protect the driver. All right. Now, aeroplane, the mass is big, right? When you move, when you are landing, right? Land. If the runway it is too short, this runway it is too short, mean it have to stop in short time. Very hard to stop. Even you can stop, the inertia is very big. So what happened to the passenger passenger inside the aeroplane? So you lunge forward. So very dangerous. So what happened is the runway have to be long. The runway have to be long runway, right? Of course, this one airbag, right? Airbag it is soft. This one is mostly it is about impulsive force already, right? But anyhow, it is when you move forward, right? You move forward, inertia move forward. So this one will protect you, right? It will protect you. So it is because of inertia, your body is moving forward, so it can protect you, right? So the headrest also, headrest, right? So when the rear end collision occur, mean the car hit from the back, so your body is at rest, so it will tend to be at rest. So your car move forward, your body still want to be at rest, your head still want to be at rest, right? So your car move forward, your head still at rest, so you will see that your head is go to the back, so you got something to block it to protect you. So this is a headrest to protect you. So anyhow, this one it is in at here, right? Impulsive force. I gave you in the notes here, my notes here. So all of this one you have to memorize, right? So airbag, safety belt, crumple zone, headrest I didn't put in. Now I can put in headrest, if you want. I forgot to put in G, headrest. Right, to protect the driver's neck. Driver's neck. Right, when real I call it real collision occur. Okay, so you can put it here. All right, here. Where is this already? Here. Here. When a real end collision occur, all right, mean real end is collide from the back, so you can protect the driver's neck. You can write it. All right. So this is inertia. So this is all the exercises. I pick it up already, and then we have done it already. So we try to have some. Alright, we try to have some question for essay lah. Essay better. Let me see essay yeah, essay don't have inertia. Got, but I sent it to you already in my quiz. I sent to you already. Alright, let me check. We discuss one question lah. Right. Where do I put it? This one. Okay. This one. So okay, now we try to have a look on this one. How do they ask question? All right. Now, let's say I look at this one. All right. You got a big tank. You got the 5 small tanks, and then 5 small tanks, and then 1 big tanks. All right. So 5 small tank and 1 big tanks. So 5 small tank, it is better to reduce the inertia. Right. Okay. So this one is inertia. Right. More number of 4 tanks reduce the effect of inertia, right? And then you see the hard structure here, all right? Why? To increase the protection, right? ABS is anti-locking brake system. It is used, right, to prevent the skid, right? Prevent the truck from skidding, or prevent the wheel from locking. All right, this one we have learned. And then size of the brake pad. This one, size of the brake pad. It is must be big to brake easily, so it can brake in can press brake more easily. All right, so answer is R. This is how you answered it. All right. Now I am doing it fast because this one revision only. If you got question, you can ask me. Alright, you can ask me either in the group or in the what. Alright, and then this is the experiment, especially for chap paper 3. This one is very very commonly asked. Right, the graph will look like this: t squared. Right, t squared against the L. So the where is the formula come from? Alright, the formula is actually I gave you before. T is equals to 2 pi sub L over G. Alright, so this is the formula. Right, if you learn it in maths, you square both sides. T square is equals to 4 pi square L G. Right, so now you plot t square, right, and then L. This one is L, right, and L. So 4 pi square over G is your M. So this is Y is equal to mx plus 0 plus C plus C. Right, so your C is 0. You don't have any C. So if they ask you to find the gradient, right, this one is your gradient. You can find how much is the G by using this gradient. The gradient is 4 pi square. So you 4 pi square over G is your gradient. All right, let's say your gradient is 1 You go and find 1. You sub 4, you sub pi in, and then this one move up, and then this one move down. So you get your G. You can find the G on your own. That's why we plot it t squared. That's why we plot it t squared, because we want to get a straight line. If they ask you to plot this way, you get something like curve. Then how are you going to find the gradient? No fixed number. No, cannot. That's why we do it t squared. All right. All right. The gradient. This one we find it. All right. The gradient is this one. Then ask you to find this one. All right. You can find. Oh, your gradient is this one 0.0412. 0.0412. And then your G is this one. We have done it. And then last year SPM. No. Last year paper 3 did ask this question. What happened to the period of the oscillation if the mass increase? So you look at the formula. The formula is t square is equal to 4 pi square L over G. It is not related to mass. Even your mass increase, the period will be the same. Not related. Okay. But for the period of the spring, it is related. Spring, it will be related. So, but pendulum bob, sorry, no. Okay. Now this is about the inertia. All right, momentum. I am not going to do it. Not my plan. In my plan. Any question here before I continue about inertia? Let me ask you one easy question. Okay, to see whether you understand or not. Okay. I ask one question. The inertia. Let me think of the question. The inertia depends on the velocity. Okay. Now, the inertia depend on the velocity, correct or not? The inertia depend on the velocity. Yes or no? Yes or no? You can vote. I don't know who is voting. Alright, no need to worry. Jangan takut. I don't know who is voting, but I know how. Later I'll know the result. How many of you vote? Inertia depends on the velocity. Okay, 6 a few watt. We wait for a while. Seven. Right. 7 a few watt. Others, uh, berdiri di atas pagar. Don't know. Alright. So, if you can see here, the answer is here. Inertia is affected by mass and acceleration, not velocity. Right? Now, there is no formula for inertia for us. For Info 4.5, don't have right mass, but it depends on mass and acceleration or deceleration. Don't have velocity. Right? If your velocity mean you are moving with constant velocity unless you stop. Unless you stop. But if I said velocity, it is wrong. Right? So answer is no. Answer is no. Right? Most of you get correct, but not all of you get correct. Still got some of you, 25, right? 25% of you get wrong. Okay? 8 of you vote, mean 2 of you get wrong. 25%. Right? Anyhow, we are going to move, right? We are going to move forward. Now, come to the part of force. I start from 4.1, alright, because if I straight away go to Form 5.1, kind of hard for you to understand, right? So now I start from very beginning. If you are in Form 4, never mind, you learn extra, right? I will teach the Form 5.1 from easy to hard. Now force. How to do the experiment, I don't want to talk already. When I see your quiz, I want to vomit blood. Really want to vomit blood. Right? So you see this one. You see this one. Right? This is your air. Right? Okay. Before this. From the new, just now we learned first law. Now this is second law. Newton's second law. Newton's second law said that F is equal to ma. Newton's second law said that F is equal to ma. When before KSSM, we don't use this one. We don't use this definition, right? We use this Newton's second law is yes, but we don't use the what's that called, force as this definition. We use force is directly proportional to the acceleration only previously, but now you have to write force is directly proportional to the rate of change in the momentum. Force is directly proportional to the rate of change in momentum. You have to write it into this way. What does that mean? F is equal to ma. I told you. So F is directly proportional to m. A is v minus u over t. Alright. F directly, if you time it in, mv minus mu over t. Right. Divided by time, I call it as rate. Right, divided by time, rate of change is minus, right? Minus of momentum is directly proportional to the force, right? This is how you write it, right? Last time you write it, F is directly proportional to A, enough. But now you have to write it completely, right? And then this formula, F is directly proportional, so it is impulsive force formula. F is equal to mv minus mu over t, right? F is equal to ma. As I taught you before, you look at this one, you look at this formula, force increase. I got a trolley. You try to think, try to think it easily. I got a trolley, right? I push with harder force. push harder, right? So force increase. Force increase, the trolley will move faster. Acceleration increase, directly proportional, right? Force increase, acceleration increase, right? Right? I push it faster, so it will move faster. I push it larger force, it will move faster, right? And then now come to the second one, right? Now here, this is a big truck, a big trolley, right? Same force, right? This one you push it 10 Newton. Now you also push it 10 Newton, right? Which one easy to move? A or B? A faster or B faster? You push 10 Newton. You look at this formula. F is equal to ma. Your force and my force pushing it is the same. So the larger the m, wah, susah mau bergerak, right? Inversely proportional. So the m 1 Newton, 1 kg, wow, move very fast, big 10, right? Here 2 kg, ooh, 3 only, right? When 3 kg or 1 only, maybe. I simply give number. So it is inversely proportional. Inversely proportional, how to draw? It is drawing this way. Chapter 1, I told you, right? Inversely. A is directly proportional to 1 over m, which is A is inversely proportional. Now, if you want to write it into the equation, I don't know, y is equals to mx plus c, y, A is equals to m, I don't know, m, I don't want to write m, I write question mark, a number. X is 1 over m. Plus c don't have, right? So this one, I don't know what is this, I time it up. A times m is a constant number, a question mark, then constant number. Let's say I call it as phi, right? Phi is equal to A times m, right? Phi is constant, 5 Newton, 10 Newton is constant, 5 Newton is constant, right? So when the mass is big, acceleration is small because you time together. Inversely proportional. Right? If you draw it this way, inversely proportional, yeah. If you draw it this way, I find it many of you get wrong, which is this one is chapter 1 come back to do revision in chapter 1. For chapter 1, give me 1 minute. Many of you said, oh, chapter 1 cikgu tidak, not important. Yeah, not important. Yeah, then all don't know. Chapter 1 update. Okay, no. Answer English one. Okay, come back to here. Okay. Okay. I take one example. All right. Don't wanna. I teach a bit first because many of you not sure. Then I have to teach. I see who first. Okay. So now this one is y is directly proportional to x. This one is y is directly linearly proportional. Linearly proportional means it is not go through 0. Right? Y is inversely proportional. Right? So now this one, you try to have a look at this one. This one is y is directly proportional to 1 over x. Or you can call it y is inversely proportional. Right? Y is inversely proportional to x here. Y is inversely proportional to x. So if you want to say it directly, is y is directly proportional to 1 over x. Y is directly proportional to x. This one, directly proportional. Y is directly proportional to 1 over x. Okay, you need to identify them. Y decreasing linearly with x, right? And so on. This one, other is not so important, right? Not important, right? Only this one, and this one, and this one. This 5 is important in objective. and when you do others, right? I'm so sad when you see when I see some of you don't even know how to answer this, right? What is directly, what is inversely, don't know. Okay, now here I still want to take one example. All right, one. Okay, if you take one example, it takes so long. This one you learn it in mathematics. Do you learn? Do you learn in mathematics or maths also got? I don't know whether you tell me got or not. Got this chapter or not? Linear law. Last time when I teach maths, it is Form 5 chapter 4 is 3, got number 3. Chapter 2 got or not? Linear law. Maths. Form 5 linear law. You will learn this one. You learned this one before? Hello? Do you learn this one before? Form 4 got Form 4 got. Then you have to which chapter? Now all the syllabus changed already. I don't know. Okay, SSM. Alright, because I don't teach since the last year that I teach is 2020. Early. Form 5 early. Then I don't teach new syllabus. Okay. Never mind. I don't wanna. If I teach that one, it will take me so long time. Okay. Now we go back to here. Now, let's say, all right, F is equal to ma. This one is F is equal to ma. F is equal to ma. Now you push with 10 Newton. If it is smooth surface means no friction. This is called net force, right? 10 minus the friction. 10 minus 0. From one basic. Maybe lah. I'm not sure. F is equal to ma. 10 minus 0 is your net force, right? Is equal to ma. 2 times a. Then you can find the a, right? 10 divided 2, a it is 5. Alright, simple. Alright, I take one more example, which is having something like got friction one. Rough surface. Let's say find the acceleration if the resistance is 5. Alright. So now 10 minus 5. F is equal to ma. Right? Net force is 10 minus 5. Is equal to ma. M is 2. A don't know. 5 is equal to 2a. A is 2.5. Of course, the thing that you need to understand is uniform velocity. When it moves with uniform velocity or constant velocity, the force applied is your frictional force. This one you memorize, then okay already, right? Okay, for example, find the frictional force of the floor if the thing move with 3 ms minus 1 constant velocity. Mean your frictional force is, you push it 10, it move with constant velocity. Mean your frictional force is 10. That's all. No need to think so much. You don't need to do until so hard. Like just 10. Finish. End of the story. Alright, so this is Form 4 one. Form 4, senang. Right? Now, how about Form 5? Form 5, you got more than one force, right? 10, 15. So you a net force. You got a net force. Right? Net force is 5. Right? If your direction of the force it is the same, 10 and 5, then same, you plus them. It is opposite direction, you minus them. Right? So of course you got 90 degree. Right? Of course you got angle. So 90 degree, you use Pythagoras theorem. I'm not going to go in detail on this one. This one I want to go in detail because this one is important. But I've just briefly go through, you know. Okay. So now, unlike from 4, just one force, now this one from 5 is, yeah, here and here. So what is the net force? Right, now, smooth surface. F is equal to MA. F is equal to MA. 15, bigger minus smaller. Always bigger, right? Always bigger minus smaller. 2A. 5 is equal to 2A. A is equal to 2.5. Right, you get it. Okay. Now, from here, this one still senang. Alright, resolution of force. Resolution of force. I don't want to go in detail. Resolution of force, right? And then here, force, I want to go into detail into this one. So much. Where? Okay, I want to go into detail into this one because the question that you asked, resolution of force, right? Resolution of force. The way that I do it is I don't care how do you do it. This is a force. If I bring to here, I touch the theta. You see this theta here? You see this theta here? Touch it, I use cos. Touch, then I use cos. I bring to here, I don't touch it, I use sine. Touch theta, I use cos. Not touching, I use sine. Then very easy already, right? So everything just solve very, very easy. For example, now this 20 Newton force, I bring to here. Touch 30 or not touch? Touch, I use cos. If I bring up, I touch 30 or not? No. No, then I use sine. Alright. So now, how to do this kind of question? Find a normal. Alright. This thing is not moving, right? Not moving. Up and down must be the same. Up and down is the same. Up equals to down. Alright, I don't want to write. So up is R. And then this 20. Sorry. Okay, now. This 20 I bring to here. Touch or not? Not touching. Not touching, I use sine. Right? Plus, because both is going up, 20 sine 30. Alright? Is equal to, wait, 19.2. 19.62. Finish. End of the story. You can find R. That's all. This thing is not moving, not moving, left and right will be the same. 2. Frictional force, I gave you as 2, here, 2, 2 is equal to 20, 20 touch, 20 touch, right? So this one, they said that it moved to the right, not, it accelerate, okay, it moved to the right, You pull it, this 20, then it moved to the right, So now, meaning that the net force is going to the right hand side. So F is equal to MA, not moving. If not moving, left and right will be the same. So this one, 20 touch 30 cos 30 minus the frictional force, right? Is your net force. This is your net force, right? It's equal to MA. Mass 2. A don't know. You can find the A, right? Very easy. Not very easy. I know from 4-1, you don't know what am I talking about. But from 5-1, I hope you know what is this. Now, come back to, I give, same thing. This one is equilibrium. I take one more before I do the example. Here, this is W. W, I bring to here. Touch 45, not? Yes, touch cos. Here, W, I bring to here. Not touching. Yeah, teacher, touch this 45. I mean, this is the angle, not this angle. Alright? This angle. So, touch, we use cos. Oh. Yeah. If this one touch, I use cos. Not touching, I use sine. Okay, now how to answer this question? Okay, now find the arrow, right? So this thing is not moving this way, up this way, or down this way. So this one is same as this one. This one same as this one. Arrow is equal to 49.5 is your weight. 49.5. Bring to here, touch, cos 45. That's all. Now this one is sliding down. I mean, this one is got acceleration. So this force is stronger, right? This force is stronger. So I say this one bring to here is sine, right? F is equal to ma. Net force this one minus the frictional force. This one is 49.05 sine 45 minus the friction is equal to 5a. Then you can find the answer. That's all, right? So of course there is still many kind of question, right? Here many. I just take one or two only. Of course, when you come to here, when equilibrium, you still got a lot. This one, this kind of question. And this kind of question is mostly the student cannot do one. I just take one only. I take one only. If not, I cannot finish. Really cannot finish. No, I don't want to do. I cannot finish. I plan to do 1 hour only. Now already almost 1 hour. Energy haven't touched yet. I find some. Okay, I simply take this one. Alright, simply take this one. Now, diagram 14 shows a poster digantung hanging on the with string and nail. The weight of the poster is 12 Newton. Weight is 12 Newton. Alright, this is T. Alright. Now, this T, you bring to here, touch 35 or not? Here. Bring to here, touch or not touching? Touch or not touching? Bring to here, touch or not touching? This one bring to here, touch or not touching? Touch or not touch? 35. Touch or not touch? 35. Touch or not touching? 35. Hello. I know some of you like to draw triangle. Yeah, not touching, you use sine, right? Okay. Not touching, you use sine, right? T sine 35 plus T sine 35 plus this one T sine 35 plus T sine 35 is equal to the down one, right? T sine 35 plus T sine 35 is equal to the weight 12. Finish. You factorize it, get the answer. That's all. Alright. You don't need to use triangle, whatever, susah. Alright. So I do one question asked by the student. Alright. You can see in the Telegram group. Alright. I copy the question. You guys like to send me Bangkok one or like that. Okay. This force and this force and this force. You got 3 forces. Force for 850. This is the direction. This is the direction. This is the direction. You got 3. So 3 normally it is not SPM, but anyhow I will answer you lah. Alright. Find the resultant force and the direction of the from the x-axis. Alright. The resultant force, this answer lah. This one should be the answer. Counter this 2 is the answer lah. Okay. Now first of all, we find the angle first. right? This angle, huh? Right? How much is this angle? How much is this angle? Right? So now we find this is opposite, this is hypo. Sine opposite over, oh no, tangent. This is tangent, sorry. This one is horizontal, right? Meaning that this is 550, yeah? 550 is opposite, and then this one is a horizontal, so tangent theta is equals to opposite is 550 over 220. Okay, theta is, get me the angle. Get me the angle, Give me the angle. Help me. $68.2, 68.2. I put it to here. This angle is not important, so 60, I mean, not important lah. 60, what is this already? 68.2, 68.2, 68.2 degree. This angle is, here it is 550, 750. This one is 750, This one same length, This length is 350. This one is 170. This is 750. So tangent, you can get the angle. Tangent of 350 over 750 mean 35 over 75, right? Shifting. To 25.02. Yeah, this answer you have done it already. 25.02. Okay. This angle, right? Tangent is opposite over adjacent. 17 divided by 75. Shift tangent. Right? 12.77. Right? 12.77. Double check. 12.77, yeah. 12.77. All the angle I got it already. Now, this question, I guess you don't copy. Okay. Yeah. Okay. I know what do you want already. Okay. Now these force go to the left. These force go to the right. These force go to the right. These force go up. These force go up. These force go down. So I want to left or right. This thing I want to know it go left or right. Okay. Now I want to know whether it go left or right. So I do it here. So long on this question. Okay. Now when it go to the left or right, so you can have at 50. Now this one, touch or not touch? Touch, right? Touch, touch. Cos 68.2. It is going to the left, right? Now not equal, so I want to see this one go to the right. I want to see which one bigger, right? So this one is go to the left. Now I use the right one. I assume it go to the right one. So I use the right one minus the left one. So where is the right one? The right force is here. I bring to here. This force right here, I bring to here. Total force that go to the right. This force is here, I bring to the left. So if positive, this one minus this one minus this one is positive, means it go to the right. Okay. So what do we have is, now I need to have another 2. Which is 450 cos 25.02 minus, right, plus, not plus, plus this one 650 cos 12.77 minus at 50 cos this one. So I know if this one is a positive number, mean it is going to the right. Okay, so I find it 450 cos 25.02 my plus 650 cos 12.77 minus 850 cos 68.2. Normally this kind of question is the question that I do in university lah, right? So it will go to the right 726.03 Newton. Right, go to the right. So hard, right? So now I want to see it go up or go down, right? It go up or go down, right? Go up. So I use up minus down. Up is at 50 sine. I bring this one to here, mean I don't touch. This one I bring to here, mean I don't touch 25. This one I bring to here, I don't touch. This one is down, right? So I am going to resolve these three forces. Right? At 50 sine 68.2 plus 450 sine 25.02 minus this one 650 sine 12.77. So I want to know if positive mean it go up, if negative mean it go down. I guess it will go up lah, right? So at 50 sine 68.2 plus 450 sine 25.02 minus 650 sine 12.77. So at 35 at 6. Haven't finished. I want to find the resultant force, meaning that this one is up, meaning that your force is going up and going to the right. Okay, so the resultant force is here. This is your resultant force. Right? So how? This one is 726.03 Newton. I use Pythagoras theorem. Here it is at 35.86. Okay, so I want to solve this one. It is Pythagoras theorem. This is, you pull here to the right. This one I pull here up. So this is your resultant force. Resultant force will be equivalent to at 35.86 square plus 726.03 square root. Okay, so this one I square, plus 726.03 square, then I square root. Answer is 1107.15. 1107.15. 1107.15 Newton. Alright, that one is your resultant force. Got a bit difference because of the decimal problem, right? Decimal problem you go round off, then you should able to get it. So the direction, we check the direction. Direction is this theta. Tangent theta is equals to opposite over adjacent at 35.86 divided by 726.03. Theta will be shift tangent of this one. That's what you have. At 35.86 divided by 726. 726.03, and then shift tangent 49.02. A bit lah. Maybe I didn't round off back good lah. Degree. Right? That's how you get it. And how we answered it. One question already took me so long. Second question I don't want to do, but I tell you how to do. You guys try to do in a group, and then show me the answer. Show I that one the working. You can wait, why cannot? Wait on. Give me 1 minute. Second question is this question. Wait, I send it to you first. If not, later. Okay, I send it to you. Or you can screenshot lah if you watch it. Okay, send it to you already. Okay, this is the second question. You can try to do it on your own. Alright, I explained to you roughly. The force here, this thing must be equilibrium. The force here to the left is the force here to the right. The force here up here, and the force here up here is the force here. And this force to here is this force to here. The force to here and the force to here and the force to here, it is the same. Then you can do it. But this one is in pound. You don't want to change it to pound, you change it to kg will be okay. Alright, because Malaysia don't use pound. Use kg. I want the number only if you want to do. Alright, you do it on your own. Alright, you do it on your own. Alright, come back to here. Come back to here. I go too far already. I go too hard and go too far already for me. I actually don't want to go that far one. Okay. Resolution. That's why when you ask me question and too hard. It will take long time. Okay. Now, lastly, we go back to here. We go to the one that I want to teach today, which is energy. Okay. So energy, it is very, very, very important. Why it is important? Because it is related to all. Okay. I don't have the notes for this one because it is in KSSM. So I just tell you what do I know. Energy, and I give you 1 or 2 example enough, right? Energy, the formula is work done. Work done is equals to power times time. Work done or energy is power times time, right? So if you want to know what is power, power is equals to work done divided by time. Power is rate of the work done. Rate of the work done. Okay. Now, apart from here, you got this one. Now, work done is also force times displacement, and this one is vector. This one also vector. Right? This force must have direction one. Right? This force, this displacement must have direction one. And weight, it is scalar quantity. No direction. Yeah, this one got vector. Yes, this one vector, but work done don't have direction. Energy, no direction. Alright, I need to tell you, you need to know. This one very, very commonly asked in the objective. Force times displacement. Okay, now what do we have is, now from here, we know that force is equal to M times A. Alright, A we call it as G, gravity. S is how high it is. So work done is mgh. What is this? This is energy. What is this energy? Potential. What potential? Gravitational. Potential energy. mgh. That's mg is force. H is displacement. right? How high it is, and then here we know that energy is not energy. We know that v square is equal to u square plus 2as. All right, we know that. Now, we know that work done is I want to change it to s. I don't want to. I just give you the formula faster, right? I don't want to derive the formula. Half mv squared. This one is kinetic energy. Kinetic energy, whereas it's come from this formula. It's come from this formula, right? It's come from this formula. Okay. So when we got this kinetic energy and gravitational potential energy, you need to know one thing is energy always conserved. Mean before and after always the same. Energy always conserved. What is mean by always conserved? I give you one example. Okay, I will always take G as 10 because easy to calculate. I don't want to take G as 9.81. Right, in the exam, you need to take it as 9.81 if it is not given. Alright, so I got a coconut tree. So let's say here it is 10 meter. 10 meter. The height is 10 meter. Now, before it drop, what is the energy that we have? What is the energy that we have? Answer me. What is the energy that we have before the coconut falling down? The coconut is, let's say, 1 kg. What is the energy? Not how much. What is the kind of energy that it has? What is the kind of energy that it has? What is the kind of energy that it has? It is? Answer me. I don't want to wait for your answer lah. So it is gravitational potential energy. So how much is this? How much is this? mgh. So I want to calculate total energy. E is equals to mgh. M 1, G 10, H 10. 100 joule. 100 joule. Alright? 100 joule. So I want to ask you, before it drop, the EK, right? EK, kinetic energy. This is potential energy, EP, energy, energy is work done is energy, same thing, right? EP, EK is how much? 0, because it haven't start to drop. No, it is not moving. No V, no velocity. Velocity is 0. Okay. Now, after when it drop to here. Here it is 2 meter. Here is 8 meter. Okay. Now, EP is at this position. How much? When it drop 2 meter only. EP, mgh. Right? M1, G 10, H 2 or 8. Answer is 8. How high it is, not how it go, how much. Alright, 2. Now it is, sorry, I said 8 lah. It's still right, 2. So it left 80 joule. Originally it is 100 joule. During the process when it go down, go to here, it left 80 joule. Where is that 20 joule going? Where is that 20 joule going? Where is that 20 joule going? 20 joule of energy going. Hello? Where is that 20 joule of energy going? Lost. Energy cannot be lost. Energy always conserved. Before and after always the same. Lost to surrounding? No. It will not lost to surrounding. Lost to surrounding, yes. But lost to what? Become what? Not lost to surrounding. Any other? I want to make you think. Where is that 20 joule going? It dropped 2 meters only. Yes, converted to kinetic energy. So EK will be 20 joule. Kinetic energy 20 joule. Now, provided when the coconut drop down, no change to heat, no heat produced, no change to heat energy, no change to sound energy, no loss to surrounding, no energy loss to surrounding, perfect. All the potential change to kinetic. So I want to calculate how fast it is. Right, kinetic energy is half mv square is equal to 20. This one 2 times to here 40. 1 half time 1 times v square. Right, this one time here is 40. V square is 40. V is square root of 40. I find it 6.32. 6.32. ah. 6.32 ah. Now it reached here. 6.32. Now I'm not happy. I said boom. Boom. Onto the ground. At the ground. At the ground here. EP how much? EP how much? When it hit the ground. Potential. Potential depends on how high it is. EP how much? How much is the EP? How much is the EP? When it hit to the ground. When it hit to the ground. EP 0, very good. EK how much? EK. Kinetic energy how much? Kinetic energy. Kinetic energy. I want to know how much is the kinetic energy at here. How much is the kinetic at here? This position. Yes. So, no matter what, at first, before it dropped, 100. When it is dropping, 100. Energy always conserved. After it dropped to the ground, 100. The energy cannot be created. Energy cannot be destroyed. Energy only can be transformed. It changed to kinetic energy. Half mv square is equal to 100. I want to calculate how fast it is. Half times 1 times v square is 100. This one come to here. V square is 200. Square root of 200, I get 13 points something. Square root of 200. 14.14, sorry. 14.14. Okay. Now I want to discuss something. When the coconut fall to the ground, the velocity supposed to be 14. But in experiment, I find it is 13.8 only. Why? I repeat my question. Boop. Theoretically, the velocity when it reaches the ground, it must reach 14.14. Anyhow, in the experiment that I do, I find it the velocity slightly lower than the velocity 14.14. Why? Why it is not chun chun? Why? 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 Yeah. Yeah. 95.22 joule only. It is not 100. Means some energy is not conserved. Why? Energy lost to surrounding because of air resistance. Some heat produced, some sound is produced. If you add in the sound energy, you add in the heat energy, maybe got light energy. I don't know. Right? Too hot, like meteor, it go into the atmosphere and then start to drop into the earth crust. Right? It has a fire. So coconut don't have lah, no light energy lah. Okay, no light energy. Maybe got sound energy. Maybe got heat energy produced. So maybe this one I take it as 95 joule. So the 5 joule lost to surrounding. 5 joule lost to surrounding. But in the calculation, you cannot. They will not give you. They will not give you. Right? Normally, we just assume there is no energy loss to surrounding. Anyhow, I'm not happy with this. Cikgu, I'm not happy with this. Just now I said v squared is equal to u squared plus 2as. Right? V at here, don't know. U, 0. Plus 2a, 10. I take it as 10, as 10. So v squared is equal to 2 times 10 times 10, 200. V squared is equal to 200. 14.14. Are they the same? Yes, they are the same. Why? Because they come from the same formula, as I told you. It is, teacher, this one no need math. Yeah lah, no need math. Why? Normally, what you do is mgh is equal to half mv squared. A lot of you know how to do this, but don't know what is going on. mgh is at here. Change to half mv squared. The mass is not important. Object 2 kg drop or 1 kg drop or 10 kg drop, the speed will be not affected by the mass. 10 times h time is equal to half v squared. 2 come to here, 200 is equal to v squared. V is square root of 200, which is 14.14. I'm sorry. That's how we do it. That's how we do it. Right? This is principle of conservation of energy. Energy is always conserved. Always conserved. Always. Right? Meaning that during the process when it going down, the energy is still conserved. Right? When it hit the ground, it changes to other kind of energy. Okay. Now I take this example. I think it is quite easy to understand. Right? So now let's say I do one question. You guys do it, try. I want to use the same question. Okay lah, give same lah. Alright. This is a coconut, right? Mass, I don't know how much, but poop, right? 20 meter. Velocity at here, how much, right? Answer. Give me your answer. Do it right now. I give you 5 minutes to do. Not 5 minutes. You guys answer. Answer the question. The coconut don't know how much is the mass. Poop, hit the ground. The height is 20 meters. How fast when it hit the ground? What is the velocity when it hit the ground? Oh, okay. I saw some of you asking question in the group, huh? Right, Telegram group. Okay. So I'll answer later. I'll answer for you later. Finish this one and I answer. Finish this one, then I answer your question. Live. Wait, I reply you. Are you watching live? If you are watching live, then I will explain to you directly. Are you watching live? Answer me. Esther, right? If you're not watching live, then I answer you later because I'm in the class. Already? It takes a long time to answer. Huh? This one you supposed to learn in from 1 to 3. Right. Mass is not given. None of you know. Just one example, two example, hard to answer. Not bad. Not bad. Okay. Shelly, very good. So we try to do it. NGH is equal to half mv squared. Why? All this one is potential energy, gravitational potential energy. Hit to here, become kinetic energy. So M, it is not related. G, we take it as 10, easy to calculate. Right, if you put 9.81, okay. H is 20, is half V squared. 2 come to here, 400 is equals to V squared. Square root of 400 is this equals to 20 ms minus 1. Very good. Okay, now come back to your question. So small. It's so hard to read. Diagram 7 shows the two speaker press 2.4. 2.4, A is 4. 2.4. This is from 4.1. The generator frequency of 450 Hz. AD work in the 6 meter in the front of the speaker. 6 meter. D, this one is D. He heard 5 soft sound and moving 4 meter. Okay. So calculate the wavelength. Okay. Now he heard 5 soft, soft, right? We got 5 soft. So here to here we call it as X. Here it is X. This one is called X. 5 soft, it is 4x. Right? So 4x is equals to how much? For after 4 meter. 4 meter. So x gotta be 1 meter. Okay? Now this is the first thing. This is the first thing. So the second thing is the formula. Alright. Lambda is equals to AX over D. Alright. A it is 2.4. X it is 1. D it is 6 meter. Right, 2.4 divided by 6. Calculate the lambda. The 450 no use one. Wait. Okay. AX over D 2.4 divided by 6. So 0.4. Answer is 0.4. 0.4 meter. That's all. Answer is A. Now, the question should ask you, V is equals to F lambda. Okay, if you wanna find the velocity of the wave. Alright, so the frequency is 450 given here. 450, yeah, 450 given. Lambda is 0.4. How fast is the sound? Sound is 330 normally. But this one's like, I don't know. Maybe 330. Sound normally is 330.4. 180. So the speed of the sound is 180. This is 1x, 2x, 3x, 4x. Why? Why? You have to see that is 5 soft sound. 1 soft sound, 2 soft sound, 3 soft sound, 4 soft sound, 5 soft sound. Distance between soft sound, it is called x. Alright. Alright, any other question? Any other question that you want to ask, you can ask me in the Telegram group or privately to me. Hey, sorry, wait. This one must be this one no use. Okay, Alright. Any other question? I guess that's what we gonna learn today. If no other question, you've got question, please PM me right now. I give you 3 minutes until 3. If you don't no question, no more question, then I am going to off the tuition today. Yeah, before that, I want to promote a bit. If you are interested into my tuition, you can click the link in the description, in my live description there. Right, there is a Google form, or contact the number. Right, contact the WhatsApp number anytime. I got English version, I got don't have VM version, English and Mandarin version. If you got any question you want to ask in the group, also can. Alright, you are not my student, you are my student, you can ask, then I will got time, then I will do it for you. Right, I try to lah. Any other question before I end the class? Any other question before I end the class? 2 more minutes before we end the class. Any other question? Huh? Want me to answer that question? Don't lah. This one long oh. Want this one One that I answer lah. Wait lah. Aduh. Okay, I will do it. Give me 1 minute. Give me 1 minute. Okay. Long oh. Okay, then I do this one. Ready? Why like that? Why like that? No, off it. What do I do? Why it become? I don't get used to it. New. Okay. Alright. Okay. This one I change it to 20 kg. I change it. If not, it's not kind of hard for you to do. And then G, I take it as 10 to make it easier. I just make it easy. G 几时要用9.81啊 ？SPM 全部用9.81，因为我要快算，所以才用10。以前呢 ，I'm sorry I use Mandarin because you asked me in Mandarin, then I answer in Mandarin. Before KSSM 我教了18年，全部都是用 G 是等于10，所以很习惯性的都用 G 等于10。好，你们呢？就是要用9.81，他没有给就要用9.81，如果他有给才用10。好，为什么呢？好，现在哈，我要你看这个哈，就是在哪里？是这个吗？我找一下哈。不知道在哪里了我。是这个呢？其实我随便点都有的啦。我要拿 SPM 的，2021的应该是。OK， 好，这个，好，是啊 ，OK， 它出来的哈，好，好看啊。This is a formula list. This is a formula list 啊。Okay. Now G is 9.81. It is given in the formula, given in the SPM. Given in SPM, so you have to follow. You have to follow. Right? G is given in SPM, so you follow. Now, you see the problem is like teacher 就比如啦，我给你一个 example 就是怎么讲？等一下哈。这样子哈，好 ，Let's say OK， 好，你看我要快算哈，OK， 这里10个 meter，right？ What is the velocity? Velocity when you hit the ground. A 14, B 20. C 130. D 5. Okay. You see when I calculate mgh is equal to half mv squared. Cancel. Right? G 10. V h 10. Half v squared. V is 200, straight root of 214.14. We do many times, 14.14. Answer is A. I use 10. Now you use G is 9.81 10. Sorry. 9.81 times 10. Half v squared. Then 2 come to here. It is I don't know, it is 200. So that's why I need to use calculator. So you see, I am like 很懒惰，我要教快我就用9.81，我就用10了。If I'm using 9.81 now you see hard to press, it take me long time. 2 I go up to okay 196 as square root 14 准 You see I use 10, I know the answer or not? No, because the answer is very far away. 一个是你9.81和10差不了嘛，你顶多拿到0.1点，无所谓啦，反正算得出来的 objective 你不用管它了，你用10也可以，它不会给你 ，it will not give you the answer like this A 14, B 14.14, C 14.13, D 14.2。It will not give you the answer like that 啦。You are SPM 啦，他们没有给你这样子的。You understand what am I saying? Objective you use 10, it is okay， 没问题的，你也会拿到答案的。但是 structural 你最好要用9.81。 因为有小数点要算出来，懂吗？或者是 SA 没有啊，没有用到9.81了，很少啊。OK， 了解吗？如果 question 有讲要用10，你就要用10。好，in Form 5 you will see，you are in Form 4 right now 哦，in Form 5 you will see，如果你没有用10的话，是很头痛的。我举简单的例子给你哈，就是你们在Form 5，尤其是算这个 spring 的时候，OK，尤其是算这个 spring 的时候，你就觉得很吃力了。你没有用10的话，很吃力，很长的时间来算比如这样子的东西这个 spring 的这个 spring 的就没有用10很不好算这个你没有用这个就很不好算哦。在这里一时找不到OK， 好，像这样子的 OK， 好，你看我给题目的时候，我要给1牛顿 W， 好，我不能给100 gram 是多少牛顿？如果你用F 是等于 mg 哦，M 0.1G 9.81，所以是0.981牛顿，不是1牛顿0.981你算的时候这里很不好算，他会拿到一样的答案。好，我 try 你还没有上Form 5好，我现在试给你好，你看你 try Form 5也可以你Form 4 Form 5都一样你看现在我给1牛顿、2牛顿、3牛顿我 example 给好，如果我给100 gram 呢？200 gram 呢？OK， 好 ，F 等于 mg，F 等于 mg M 是0.1math G 是9.81，我用9.81的话0.981是1牛顿好，如果是2牛顿呢 ？OK， 好，现在我现在算F 等于 kx， 现在它的 formula 0.981等于 k， 然后 extend 2cm， 然后除过来 k 是等于你要半死真的是你看就很头痛咯。问题就在这里了，0.981除以2 0.4905，OK 是0.4905牛顿 per cm， 然后我拿到这个我拿到这个如果我用1牛顿的话我会拿到比较美的号码，所以很容易算，这个很难算好，不要紧，我们来看，如果200 gram 呢，我要找 y，F 等于 kx，F 2牛顿mg 0.2乘以9.81，2牛顿等于 k 0.4905，然后 x， 然后算 x 是多少？算 x 0.2乘以9.81除以0.4905是你的 extension， 你的 extension 是4。看我在这里 F 等于 kx， 我就算出来 x 等于4了是不是一样的答案？然后原本是10，你再加4是4我为什么要用9.81呢？Instead of 如果我用10，你看我用10，它就很容易算就在这个情况之下，不然这里你如果 run off 了小数点这里全部都走完你等一下你会拿到这个很长时间明明是4你们会拿到这里5不要啦，老师这个什么这个5不用然后你就拿到3.92 cm， 然后老师就打你错，原因是在为什么在这个情况之下，他们要用 G 是等于10，比较容易算，没有其他的原因。还有吗？好， 这一题哈，要我算这一题啊，我就算了。很难哦，不是很难的。好，先找这个 angle 来 ，OK， 来，就算这个 angle 起来，这个 angle 哈，这个是 opposite over adjacent shift tangent 3/4 3/4 shift tangent 36.86 36.86 ，OK， 好，你应该有看吧？啊，应该有看啊。好，我先写第一个 equation， 哎呦，很长。好，我先写第一个 equation 哈，左边的你右边的，这个 the A has a 20 kg， this one 20 kg 啊。Okay, so I write the equation, you go and solve on your own lah. So the left hand side, the force, this is T, right? This is T, TDC cos 36.86 is equal to TEA cos 45. Up and down. TDC sine. This one also go up. Weight B is equal to going down one. The force that go up, the force that go up is equal to the force that go down. You got two equations already. Now you need to solve this one. This one, Now the force go to the left is TEC ZZZ 45. Go to the left. Go to the left. Is equal to this one go to the right. TEG ZZZ, here it is 30. So sine 30, not touching 30, not touching 30. Then go up, the force go up. The force that go up is TEG cos. The force that going down 20 now I time 10 200, right? Weight 200 if you 20 then you time 9.81 you'll find it 哎呦很难why would I use 10 faster? Okay, if you want to use 9.81 then okay, this one supposed to use 9.81 but I don't want 就不要 plus TEC bring to here cos Z this one 40 sine 45 EC sine 45 for equation. Now from here this is number, right? You can see this is TEC. You can substitute this one into here. Set into here, you got TEG already, and then got number. TEG you bring together, you can find the number already. After that, TEG is, you find it already, you can find TEC. TEC is here. TEC is here. You can find it one by one. You substitute and find back. This one I didn't write. You screenshot this one to get the answer on your own. Right? You do it for me. You do it on your own. If you cannot, you PM me again. Any other question before I end the class? If no, then I am going to stop here. I will see you again. Alright? Bye bye. 上了2个小时的课，大家都辛苦了。
谢谢你们又专心上课，下个星期一样。